Engineers today, across all industries and disciplines, are facing the challenges of greater complexity of design. To deal with this ever-increasing complexity and the mounting costs that come with it, engineers around the world are demanding advanced modeling and simulation solutions that will help them meet the modern engineering challenges they face. Because mathematics lies in the heart of every engineering model, MapleSoft recognized that they were uniquely positioned to develop MapleSim, a high-performance physical modeling and simulation software solution based on their core symbolic mathematics technology, Maple. MapleSim gives engineers the tools they need to develop extremely efficient, high-fidelity models of complex multi-domain systems in a fraction of the time required when using traditional tools alone. With the help of MapleSim, customers in automotive, aerospace, green technologies, power industries, electronics, and more are successfully meeting the challenges of today's complex engineering projects.
The strengths of MapleSim are the ability of the engineer or scientist to be able to rapidly build a model. Speed is the name of the game in almost every development process today. The company that gets to market first has the advantage, no doubt about it. And one way to get to market first is to make the design faster. And anything that can be done to do that is beneficial for a company trying to build a product. And MapleSim does just that.
We as a society are requiring more and more out of our technology, and that technology is becoming more and more complicated. In particular, not just complicated, but it's multi-domain, multidisciplinary, and you have to understand the interactions of these systems together in a very fundamental way. And if you don't model the systems in advance, you are more likely to encounter serious errors in the long run. So modeling is absolutely crucial for complex systems, multi-domain systems.
It's unbelievable how complex now control systems are compared to what they were when I first started designing control systems. Many control systems nowadays have unbelievably complex dynamics that they must deal with.
We model our autonomous flying vehicles in advance before we actually try to fly it, because once you fly it and it crashes, then you've spent so much money that you can't recover. So simulations of complex systems is important in advance of implementing. Hardware-in-the-loop techniques are important in advance of integrating complete systems. That's the only way to get success faster than going through the tedious steps of trial and error as opposed to simulation.
The easiest way to reduce that time to the market is to use good mathematical models, because that way you can reduce the number of prototypes that you are making, because you can predict much easier what your system would respond, what your system would react. And I think that will be, or it is, crucial to any product design.
MapleSim, which is built on the same powerful symbolic technology as Maple, is a drag-and-drop physical modeling tool that makes it easy to develop models of multi-domain systems, including plant models for control applications. These efficient, high-fidelity models can be analyzed and optimized with MapleSim and connected seamlessly to existing tool chains, including popular platforms from the MathWorks and National Instruments.
MapleSim does something that for many would seem miraculous, because without MapleSim, it's really difficult to do, and that's to generate or to derive the equations, the model equations for something you're designing. If you were using the traditional tool set today, you would have a stage in your project where you're sitting at a desk with reams of paper where you're massaging algebra, possibly day and night for weeks, if not months. And it's all manual, it's all painful. MapleSim miraculously gets rid of that.
The real power of symbolics for me is to generate very fast simulation code. And it's not obvious to most people how that happens. But if you have a symbolic expression for your system model, you can simplify that expression, you can extract repeated terms and compute them only once. At the end of the day, you can generate highly optimized simulation code from a symbolic expression. And for us, we do a lot of real-time simulation, we do a lot of hardware-in-the-loop simulation, and all of that work is facilitated by the symbolic approach that's embedded in MapleSim.
Engineers everywhere are applying the powerful symbolics of MapleSim and Maple to a huge variety of applications, everything from batteries, bicycles, and excavators to electricity cables and wind turbines. Leading organizations and institutions around the world now rely on MapleSim to reduce project time and cost and bring products to market faster.
The main reason that we use Maple and MapleSim in my project with Canadian Space Agency has two probably main aspects. One is to be able to have a good model. The other one is to be able to use again that model in hardware-in-the-loop experiments. We investigated other software packages, and we realized that it could be a seamless integration from the modeling to hardware-in-the-loop and validation. And that's why we are using Maple and MapleSim.
There's been growing interest in unmanned vehicle system controls in a variety of applications. And in order to develop unmanned systems safely, you have to go through the steps of designing them with simulations, simulating the system, and then eventually deploying it on the real thing. Our Q-Ball, which is our flying unmanned vehicle, was designed using MapleSim and simulated using MapleSim. We developed the differential equations using MapleSim, and as a matter of fact, we discovered, some behaviors in the system that we had not taken into account until we ran the MapleSim simulations and found some couplings in the system that we had not, considered in our design.
My desktop computer has more compute power than I had available to me and NASA had available to it over the entire duration of the lunar landing program. And I had a tool like MapleSim and Maple and all of the computer power that it involves. There is no doubt in my mind that a process that took about 3 to 6 years, depending upon where you start and where you stop, would have been short-circuited down to a few months. No doubt about it.